We are going to move on to our next session with Faris, and Faris will be focusing on utility scale ESS solutions. All right, welcome, Faris.
Thank you.
Give a quick word of introduction about you before I hand over. So as I said, you are going to be telling us about Envision and about your utility scale ESS solutions. You are the client director of Envision based out of Dubai, bringing today 20 years experience in renewables, healthcare, and defense also. With regards to renewables, you were previously the sales director for PV and BESS at Huawei, as well as the regional business development manager at Envision. And if my information is correct, you graduated from West Point in the US. Is this correct?
Correct. Where do you get all this information from?
Oh, we are connected. We do work. No, but I'm very pleased to welcome you today, Faris.
Thank you.
Over to you, Faris.
Sure. So we'll talk about Envision company as a whole, and then I will talk about the challenges of utility systems and why is the trend going towards utility systems as well, and then talk a little about the products of where the market is heading. So if you look at Envision Energy as a group, we are comprised of multiple companies, all focused on renewable energy or sustainability of the future. So Envision Energy Group, we have manufacturing of the cells, we have the capability of software providing, we have an investment arm where we would invest in technology company, which is the one we are working on. Envision Energy Company is the end-to-end user, is the end-to-end provider that uses the back end of Envision Group and has one point of contact with the clients. So as Envision Energy, we are rated the #1 supplier globally in the wind in 2023. We have integration end-to-end from the battery solutions for the BESS, with a huge utility scale capabilities. We provide hydrogen solutions, as well as taking a step further and creating a net zero park. And finally, we are the champions of Formula E, which is Formula F with the e-vehicles. So as a company, we believe in the global presence. So global presence will mitigate and give advantages for the company. So how I say mitigate, it will mitigate the supply chain of the products. So we have, let's say, multiple factories of cells or integration globally. We have multiple factories of the wind, from blade to different things. We also have almost 20 R&D and offices on a global scale, making us closer to the clients and attracting talent on a global scale. So this is where we present ourselves as a global player, while being closest to the client and utilizing the global power of talents. So as a renewable energy, let's say, we believe in renewable energy system is the cornerstone for achieving a net zero transition. So what does this mean? This means that we want to connect all the traditional and the renewable energy on a single platform, where in the future it could be considered as a VPP, which is a virtual power plant. We look at things on a large scale. So the EnOS is a AI capability where it will be able to manage and operate the batteries as the backbone of the whole system. When I say batteries, why? If you look at the left side, the net zero supply or renewable energy supply comes from three main sources. The batteries, the wind, which is very common in different areas. If not wind, it's solar, and then the batteries. The main difference of the batteries, or the main advantage the battery gives, it's one of the only renewable source that could absorb and give when needed. And it will be the way to stabilize the grid in the future. If you look at on the right side, there's the consumption area, and what we believe is in the future will be even microgrid capability. So on the Net Zero Park is one of the demonstration parks we actually built. Net Zero Park is one of the parks we actually built, which is almost 100 megawatt park, where you need more than 150 megawatt batteries, 500 megawatt solar. It's actually up and running park, ready to visit in China. And we believe this model, where you could create a full capability of industrial park powered 100% renewable, will be the next, the future. So it's more of a microgrid capability in that sense. So coming to why are people using more batteries, or why is the industry looking in utility batteries? It has a lot of advantages, but with the growth of renewable energy. So let's look at Africa. Africa is the second largest continent in the world, and it has the most, I would say, potential in the sense of growth. It has a lot of countries. It is lacking a lot of countries are lacking the power, and when there is a power, there's also somewhat of a weak grid. So with the growth of renewable energy, because of the pricing, because of easiness of installation, because of the huge supply chain that's coming into the world, it is growing so fast that the renewable versus traditional energy has, I would say, it has the highest percentage on a global scale. Other countries could have, let's say, 100 megawatt with 20% penetration. In African markets, it's much faster than this. So as we come from a traditional to renewable energy resources, we look into the system inertia decreases. What does this mean? So this happens when there's so much more penetration to the grid using a non-direct connection of power. When I say non-direct connection, it's like in a wind turbine or in a solar farm, there's an inverter. Inverter creates a different connections to the grid, which creates, I would say, noise or problems on the vulnerability of the grid. So the three main topics that globally is being considered when the increasing of renewables is the vulnerability of the grid. So the more renewable coming into the grid, it is making a lot of noise and a lot of disturbance for the generation. And with this, it doesn't have enough inertia. And with not enough inertia, it is creating frequency drop, which leads to instability. Another section, which is the high rate of discharge frequency, which we call it ROCF, and the high rate of frequency levels challenges the power system control, causing again instability and not being able to manage properly. And finally, we have the SCL or SCR, depending how you look at it, which is shifting towards renewable energy, leads to a low short circuit levels. This means fewer fault current systems, making it harder to maintain a stable voltage and frequency in the island grids. So what we think and what we predict the future coming. So as we said before, our colleagues before had residential systems, other colleagues had CNI. Now we're looking into utility systems. Utility systems are either IPP or really supporting the grid of a national country, or the national grid of a country. So as renewable increase, we need to move towards something called grid forming inverters or grid forming PCS, not a grid following. What does it mean between grid forming and grid following? So when we talk about grid following, it is basically an inverter or PCS that needs a strong voltage reference signal or something PLL, phase locked loop, to be able to synchronize. This means that unless we have a very strong voltage and a very strong grid, the solar will be limited, or the renewable energy penetration to the grid will be limited. So the more we connect, it will be becoming more of a problem. So the grid forming inverters have to come from the wind or the solar, and in the battery, we call it the PCS. So the grid forming will help stabilize the grid. It actually will be doing four different things. It will be doing impedance operation, enhancing stability. It will help the seamless integration when you're looking into microgrid capabilities, and improved in the control for the user or the grid operator. So when I say impedance of operation, so the grid forming inverters can operate independently without the need of a strong voltage reference. It creates its own voltage reference and frequency, and could maintain the strong and could maintain the voltage and frequency, creating like a virtual capability, which is a hardware and software. And this is the future that we believe. Enhancing stability can respond to more effective to changes on the grid conditions, such as sudden loss of generation. So let's say there's a cloud that comes over the solar system, there's a huge drop. You need to be able to stabilize the grid very quickly. Seamless integration, again, microgrid, which is something getting more popular. There's a few projects in Africa where they're creating microgrids for small villages. If you look at a massive microgrid, I would say Saudi Arabia has one or two operations that are looking into it, but this is the cities of the future look like. And obviously the improved control for using the grid forming capabilities. So I want to give this, where is this? Okay. So I want to give a story, just an example, using one of the most mature markets globally, which is, I would say, the UK market. Why they have started looking at batteries, not only because there's no power, but because it is actually viable to use batteries even in a mature market like the UK. So let's consider the UK market grid as a orchestra. So and in this orchestra, you're going to use different harmonies, different musics, and this is called like the power source. And this power source is using different instruments. So you'll have renewables from one part of the instrument. So you're going to have traditional, which is another part, and the rhythm, which is what will be changing between traditional and normal, is we could call it the inertia. And most of the money that is used to keep the grid operating and stable is costing 50% almost of the cost of running the grid of electricity is using for stabilization, which is a huge amount of money. So if you're able to do this using non-traditional sources of energy or non-carbon, like in a grid in the UK, they're using, for example, a lot of auxiliary powers to stabilize and using traditional transformers, which is also carbon emitting. So what we've learned as an example there, they used out of experience, they used grid forming batteries as one of the things. They use grid forming inverters, they use supercapacitor, hybrid solutions, they even synchronous condenser. So they use different testing, and they found out that two technologies, which is one, the grid following batteries and the synchronous condenser, are the most suitable because they cover bigger ranges or different ranges, but they could compensate. Sorry, no, they could compensate for the auxiliary powers of the grid and using zero carbon in that sense. So my second part of the presentation is just giving a more introduction about the energy storage systems, and especially on the utility scale, and understanding how the efficiency go up and the trend of these things. So in the utility system, we had the cabinet solution was very popular before, and now there is something called the container solution, which has gained popularity over the last, I would say, year. So previously, we had some colleagues talking about the full stack technology capabilities. What does it mean? Full stack, they said they look into the raw materials all the way to the battery manufacturing. And then we looked into, from the battery manufacturing, the integration, then the PCS, then the control system. So with Envision Energy, we actually take it a step further. So we don't only take the raw materials, we have invested in raw materials, we have our own capabilities of manufacturing cells. We're almost 60 or 70 gigawatt hours now with production. Again, we have our own in-house PCS, which is a grid-forming PCS, which differentiates us from a lot of other suppliers. And then the integration of the container, and finally the control system, which is powered by AI, and we could actually do fault detection, everything in-house. So here it says Tier 1 OEM by Bloomberg. I was trying to research what does it mean to be Tier 1. Bloomberg, I personally believe, is taking a general look on what does Tier 1 mean, specifically into the industry. Doing a little research, I saw some articles that say we consider Tier 1 as suppliers who are able to manufacture cells and present them, and they're used in international market of EV because of the highest safety regulation. Second part is producing EV cells, or producing cells that are used in EV cars in China. And the third tier is only cells that are not used in EV standard. So when we look at IPP, or when we look at utility systems, we look at a lifetime. And high security, low cost is, and safety obviously is the main factor of installing these big batteries. So the trend is having more dense batteries, and we have many suppliers doing different sizes of batteries. But if you look at the density, it has grown about, I would say, 11% year on year versus a tradition versus what it was before. Not only we look at the cells itself, we're looking at the lifetime of the battery itself. So now we are reaching almost 12,000 cycles. We're capable of reaching 12,000 cycles plus with our batteries. We could even reach more than this depending on the advanced technologies and how we control it, coupling it with solar or wind. We're able to reach a lower LCOE due to different factors of longevity or even more condensed in one location. So just give you a small briefing about different applications we have installed. We as a Envision Energy, we have shipped more than 10 gigawatts of systems. We have more than 200 operations globally, and we are having a very healthy pipeline over, I would say, 15 gigawatts in the pipeline. So we control the supply chain, and we have a good pipeline. So we're able to deliver on time all the time. So the future, or the trend, is moving towards a containerized solution. So we've seen containers we used to be 2 megawatt. Now the new containers are 5 megawatt condensed containers. And the most important part of a utility system is, I would say, safety. Safety is one of the most important, and then being able to meet a lower LCOE to different factors. So in a 5 megawatt container, for example, we're able to fit in, I would say, 20 megawatt blocks. Why? A 5 megawatt container with advanced cooling systems will be able to give us access from one side. We don't need access from all sides. We have a liquid cooling capability. And as you could see here, giving us, for a 100 megawatt system, which is 10 cents, we need only 1,800 square meters versus what we used to have with a cabinet solution, much bigger footprint, almost double, 3,700, versus an air-cooled solution where you need to open all 4 doors and we have to space them out. Here we could actually you could save up to 50% footprint, which means less BOP, less trenching, less cabling, and less land. What does this mean? We could actually fit it inside a PV land, a PV farm. We could fit it next to it. You could fit it next to a wind farm. And this 20 block utility system will be coupled with an AC system, as you could see here, of 5 megawatts, 2.5, 5 megawatts AC, giving us an optimal size and the lowest LCOE. This is the example of a 4-hour configuration, which is the most present. So again, how to lower LCOE? We talked about higher density. We talked about longer cycles. We talked about smaller footprint. Now we need to look into the two factors that are left. One is operation maintenance. So using the AI algorithm within the system of BMS, EMS, and our EnOS system, we are able to detect faults. And when we detect faults or pre-detect faults, using preventative maintenance, we could actually go to the site and replace it. So the faster we replace, the higher availability, the more money we could save, the lower LCOE. The second factor is having technology. So we have the AI technology, which is on the system of preventative maintenance. Now we need to make sure the batteries live as long as possible. So some systems or some clients are asking us for 20 years, 25 years. Now it becomes challenging. How to maximize the lifetime of the batteries? Obviously, we need to have the temperature difference to be as close as possible to zero. So 3% is one of the what we think is an average standard in the market. And because we come from an international supplier of EV cars, our pack level is extremely high quality, and we have our unique cooling system that goes on a pack level, then comes from the container level liquid cooling. Now, going back, using the liquid cooling with a smart system, so you could have a liquid cooling, but part of the liquid cooling is auxiliary power. So instead of selling the electricity, you're actually burning the electricity through auxiliary power. So now what we did is we took it a step further and we created different modes. And using smart AI will actually tell us which mode will the cooling work on, and from that we could actually save the auxiliary power. So as you can see here, the temperature uh, when it's high, usually a traditional auxiliary consumption is in the blue, versus where we're actually looking into the orange, where we could optimize. And this gives us the advantage of reducing auxiliary of 30%, which we could sell the electricity or save the money in different countries. And now one incident could affect the whole industry. So safety, 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 safety of equipment, safety of personnel, safety of the image of our whole industry. It's a very fast growing market. And the only thing that could hurt us is actually not having having a bad image in the industry. So an example, one container of ours has almost 3,000 sensors of only temperature, where every pack has 60 sensors. We have multiple packs. Then we have when we look at the different fire suppression system, the gas detections. So we need to make sure safety is on the maximum capability or on the maximum image, and we could actually provide fire rating enclosures up to 2 hours if something happens. And including safety is we need to look how to transport these things. So now we have a big container where it's almost 40 tons or plus 40 tons plus of weight because of the density of the batteries. How we transport them, we need a special container, which is worst case scenario, earthquake proof or transportation proof. So we need to make sure the steel structure, everything there is holding the weight, because one battery that is damaged could be the weakest point, which could lead to a fire and could lead to the safety of the whole plant. So this is my contact email. I know probably utility system is contacting more IPPs and government entities, but please feel to email me if you have any questions.
Thank you very much, Faris. Impressive presentation, opening our eyes on a brand new side of our industry. There was a lot to present, so we went a little bit over time, and I've got quite a few questions to ask you. So I'll shoot those questions to you, and I thank you in advance for keeping the answers short so that we can address as many of them. First of all, Envision is a little bit of an unusual company in our industry because what we have seen is like traditional solar companies developing skills into storage. In your case, you come from the wind background, and now you are also moving into the storage. Just to be clear, are you providing your storage solutions only in connection with wind projects, or is this a completely separate activity and you can do the storage component for a connection with a solar project or a standalone project?
So we don't work only with the wind. If it was a wind project, we get an extra advantage because we have I would say, advanced controlling system where we could actually work with the wind, self-learn using our advanced controlling system, making sure that lifetime battery goes longer. But no, we are working with multiple projects now on standalone system, and in China we have a huge track record. In Europe, specifically in the UK, we had a extremely successful year and with a huge pipeline. So I would say no, we work separately.
At some point in your presentation, you mentioned 12,000 cycles. Took my calculator very quickly, and if I calculated one cycle one day, I reached 33 years. That is a considerable difference with what we are used to with batteries. Can you please explain this? Is this for real, or am I understanding it wrongly?
No, it's we have to look at it from a different perspective. So there is a degradation per year, and there is also the cycles that will affect the battery lifetime. So this is the industry trend is going towards longer lifetime. So yes, we are exceeding 15 years in the lifetime battery, but also sometimes you could use 2 cycles per day. Sometimes you use 3 cycles. It depends on the application that is used. But the longer cycles we have, the more, let's say, LCOE we will be getting, LCOS in that sense.
And you also mentioned in relationship with those cycles, if I understood you correctly, you said that those 12,000 cycles could actually be improved if if the storage is combined with PV or with wind. Can you please explain how that works?
Okay, so it will improve when we're using our own, let's say, smart algorithm. So in the sense that when we look into a traditional up and down cycle, uh, combining it with our algorithm, we could see how to charge the batteries on optimal times and how to discharge it, giving us an additional few years in operation for that operation. So it is, I would not say black and white. It depends case by case, project by project, on the simulation for that specific project.
You you mentioned that you've been already achieving some amazing success in China, in Europe, in the UK. Here in this session, we're focusing on Africa. I would like to hear from you how you feel the maturity or the level of understanding currently is. Those projects, they are government projects. They are being led by tenders, and IPP developers, equipment manufacturers, they provide what is being asked in the tender. Do you feel that the national utilities in Africa are already informed enough? Do they understand the benefits of those large-scale storage solutions, or is there more work needed?
To be honest, I would say there's 3 countries that are, I would say, leading the battery storage systems in Africa. Obviously, South Africa, which is the largest market, and it is by far, I would say, the most advanced in the sense of the battery capabilities or looking into what the capability of battery will bring to the country. I would say Morocco is also has a huge pipeline and a few tenders. And then we have Egypt, which is coupling the batteries with current systems and looking into how to get it into a hydrogen business. So these 3 countries are ahead in the sense of the utility system. But there is a lot of other countries with a smaller system, 1 megawatt, 2 megawatt, 5 megawatt. For utility, these countries are ahead of the market.
because at the same time, if we compare globally, Africa, we know that we have some relatively big issues with grid stability. And so if there is one place on Earth where the battery could have the biggest impact, it's probably in many African countries.
Correct. Correct.
Last question for you. You mentioned several times about the mini grids. And yes, I mean, mini grids is a very big topic in Africa, and there's a lot of hopes related to mini grids for rural electrification. But we know that there is also a big challenge with regards to the cost building those mini grids. I was wondering, with your expertise in wind and your expertise in storage, did you already manage to identify some cost saving or cost lowering situation where a mini grid, even though it's a small system, would be better if it combines PV, storage, and maybe like a small wind turbine?
Well, to be honest, any source of energy, clean source of energy. So solar, wind. If there's wind, great. Most microgrids have solar because solar, the sun, and specifically in Africa. And then you need to have the battery system, which is, I would say, the brain behind the whole operation. Specifically, when I talked about the PCS, the grid forming, because you could use a diesel generator or you could substitute the full diesel generator with a microgrid renewable. So if you use a diesel generator, you're still operating the diesel generator at 30% to create this microgrid with the diesel generator, which you're still burning 30%, you're still doing emissions, and you still need to truck this diesel and maintain these generators, which will increase the cost. So if you're able to take out the diesel generators or traditional way and specifically rely on the battery and having diesel as a backup completely off, then you're able to maximize or becoming more and more viable option in the microgrids.
Thank you so much, Faris. Very clear, very comprehensive.